Okay, in this little video I'm going to go over the second part of the lab, which is looking at chemical and biogenic sedimentary rocks. These are things that have been precipitated out of water either inorganically or organically. Some sort of organism created a shell, pulling different elements out of the water, created that shell, and then the organism died and its shell later became sediment that turned into a sedimentary rock. I'm going to just talk about some differences between them. Again, when you're doing these comparisons, I am providing you the samples. I'm telling you which samples are reacting with hydrochloric acid since you don't have hydrochloric acid. If you put a drop of it on these samples, they would fizz or bubble or effervesce as carbon dioxide is escaping out of that mineral because of the reaction with the acid. When you look at question 13, oolites often are confused with sand-sized particles. These are going to be things that are made of calcium carbonate, so calcite mineral. They're going to be white. They tend to look like gobstoppers that have had all of the colored dye kind of licked off of them. They're going to be very white to pearly. They don't look glassy, and if they've been cut in half, you'll actually see concentric circles on the inside. Okay, I'm going to scroll down and start looking at the classification scheme. The first thing that we look at when we're identifying our sedimentary rocks based on these chemical sedimentary rocks, we're going to look at composition, what it's made out of. The top group, these are all calcium carbonate. So we're trying to look at differences in what we see. If we see well-cemented shells or rock fragments that are all together in that particle, this is going to be a fossiliferous or skeletal limestone. The grain size can be anything. We don't have to have all fossils, but if we see enough fossils inside of it, we're going to call it a skeletal limestone. If we see those little oolites, we're going to call it an oolitic limestone. Oolites form in shallow, warm water, like what we would find off of the Bahamas, where we have a current moving back and forth to allow calcium and carbonate to precipitate around a small little grain of sand or a shell. And they're going to grow over time with agitation in that water. No other process is involved. Okay, if we see nothing, maybe some little crystals, but no fossils, we're going to call the rock a chemical limestone. This would be something that's precipitating out of water that has a lot of calcium in it, a lot of carbonate in it, and as the water starts to evaporate away, the water becomes enriched in those two ions, and limestone or calcite is going to precipitate directly out of that water to create the chemical limestone rock. Okay, dolomite is a little bit different. When we have something that's made out of dolomite, it's very similar to calcite, except it doesn't react with hydrochloric acid unless you grind that rock up first. And that's because dolomite has magnesium in its chemical formula as well as calcium. It makes it a little bit stronger, so it's more resistant to that reaction. If it's made out of the mineral dolomite, we're going to call it a dolostone. Okay. The next samples that we're going to look at, if you find something that's made out of quartz, what you're going to see in these samples is they tend to be dense. They're going to be opaque. They can be white, cream, gray, pink, many different colors. But what you're going to notice is that they exhibit conchoidal fracture. Okay, so you're going to look for those scalloped edges on the broken surfaces. And the name of this sample would be called chert. Okay. If you have a rock that's made out of the mineral halite, it's going to be rock salt. This would be a sample that if you were to lick it, it's definitely going to taste salty, and it forms by the same precipitation that we saw with that chemical limestone. Gypsum is another mineral you might see. It's going to be soft enough that you can scratch it with your fingernails, and we would call it rock gypsum. Peat and bituminous coal are the two really organic samples that you'll see. Peat tends to be brown and porous and pretty fragile, and bituminous coal has undergone some more burial, so it's going to be denser and darker in color, brown to black. It's non-porous. It may have some of the pre-existing layering and a little bit of conchoidal fracture, but you can tell them apart definitely because the bituminous coal is going to be denser than the peat. And that's it for those samples.